Hello, and welcome to the React World Tour, the San Francisco Real World React Edition. My name is. Let's My name is Benjamin Dunphy, and I organize the two largest meetups in the San Francisco Bay Area. And I also produce Reactathon, the largest independently organized React conference in the US. And tonight we have three amazing speakers joining us to present on a number of React-related topics, including React 18, dynamic content with Jamstack sites, and a third topic as mysterious and elusive as our third speaker. But first, I would be remiss if I didn't mention who is responsible for putting this event together. This DOT is a force in the world of modern technical consulting, agency work, and community engagement and events. They partner with enterprises to provide architectural guidance, staff augmentation, on-demand experts, and more. So if you're interested in learning about that kind of stuff, head over to thisdot.co. That's thisdot.co. Okay, so before we get to our talks, I do have one quick announcement that I'd like to make. As I mentioned in my intro, in addition to the meetups that I organize, I also organize Reactathon, the San Francisco React Conference. And while it's been nearly 2 years since we were forced to take Reactathon online, I'm really, really pleased to announce that Reactathon is returning in person this May. Dustin, if you could share my screen. All right. So we announced it on Twitter. We had a few of our speakers announce it with this fun, clever meme announcement that we came up with, where Kent is saying, "I'm speaking at Reactathon in person," and the crowd goes wild. And the other thing I really like about this little announcement that we did, leveraging video, is it also shows a lot about the just incredible venue that we've selected this year, in addition to the number of safety precautions we've taken, because I think there's a pandemic or something happening. In any case, this is going to be one incredible event. It's completely outdoors at what I think is the most gorgeous venue in all of California. Not just as outdoor events go, and everyone's going to be fully vaxxed, everyone's going to be fully tested, and again, everything's completely outdoors. So very safe. If you want to learn more about that, please head over to reactathon.com. You can learn more about the events, our wonderful sponsor, presenting sponsor, Vercel, and all of the speakers. So far, we've confirmed a number of folks, including Ryan and Kent and Lydia, Wes and Scott, and many more. And lastly, we also have a full day dedicated to serverless talks called Serverless in the Park, featuring a number of folks, including Simona Cotton from Azure, Matt Billman, the founder and CEO of Netlify, Jeremy Daly of Serverless, Farrah Campbell of AWS, and Brian LaRue, the CTO of Begin.com, in addition to many others. And the inimitable Anjana Vakil is returning as the Master of Ceremonies. So head over to reactathon.com, and we look forward to seeing you there. Okay. Now, Dustin, if you can stop sharing my screen, I'll move on to the next subjects. All right. And with that, let's get to our talks. All right. So today's first topic is React 18. Now, as many of you know, the React 18 release candidate was recently announced by the core team at ReactConf in December. And what this means is that pending additional feedback from the community, this is the same version that will ship into production. And true to form, it should be fully backward compatible. But what is in React 18? And what does this mean for suspense and for concurrent mode? Today, we have senior software engineer Shruti Kapoor presenting to help us answer those questions and more. And if you don't know her personally, then you may have seen her tweeting at Shrutikapur08 on Twitter, or speaking at one of the many conferences she's spoken at around the world, including ReactConf most recently, and also GraphQL Summit. And when she's not doing that, she's writing code for PayPal as a senior software engineer. I'm really pleased to welcome to our virtual stage Shruti Kapoor. Shruti, how are you doing today?
Hey Ben, I'm doing great. How are you doing? Thank you for that wonderful intro.
Absolutely, yeah. It is absolutely my pleasure to have you here. I saw your talk at ReactConf, and I'm really looking forward to seeing either the same thing again or maybe some updates. So I don't know if you have the inside scoop on what's been happening or when React 18 is going to be fully released, but I look forward to hearing that.
Sure thing. This talk will be a easier version of React 18's React Conf, um, keeping in mind the audience. So I'll try my best, but I'm gonna try to keep it very simple so everybody can be on the same page.
Wonderful. Well, I'm going to head backstage and I'll let you take it away.
All right, thanks, Ben. Hey, everybody. Thank you so much for coming to this meetup today. First of all, this is the first meetup that I am speaking at, but I also know this is the first meetup that a lot of you are going to be attending. So, welcome to another year of meetups and conferences. If you can hear me, please say hello so I know that I'm not just speaking to the void. So, today I'm going to be talking about what's new in React 18. I'm going to be talking about a few new features of React 18. Specifically, I'll talk about the Create Route API. I'll talk about automatic batching and start transition. Hello, this Start Media and Dane. So before I get started, Ben already introduced me, but I want to formally introduce myself. My name is Shruti Kapoor. I'm a senior software engineer at PayPal. You can find me on Twitter at ShrutiKapoor08 or on Twitch at twitch.tv/ShrutiKapoor. This is my first week trying out AirPods. So if you see me touching my ear, it's because they keep falling out. So I'm going to try to keep them on. So, okay, we're going to be talking about some new features of React 18. I'm going to be talking about these three new features: Create Route API, automatic batching, and concurrent React. So, first of all, as you may be aware, React 18 is currently in the beta version, which means that all of the features that are out there are pretty much stable. You're free to try it out. What you see is probably what you're going to get. And so some of the features that we're going to talk about today are also going to be like start transition, use deferred value. I'm going to be focusing on what is concurrent rendering and what is concurrent React. One thing to note about React 18 is that the upgrade to React 18 is going to be easy. It's as simple as doing an npm install. Most of your code should work as is. There shouldn't be any breaking change, but we're going to look into it in a detail on about how you can upgrade your current app from React, whatever you may be running 17, 16, to React 18 with just one line of code. Another new thing that came out with this React 18 release is also the React 18's working group. I'm also a part of the React 18 working group, and the idea behind the working group is to get the community together early enough so that we can get feedback on React 18's updates, put it out in the open. React 18 working group is a group of folks who are educators, community members, library maintainers, and the idea is to get feedback from the community as early as possible. So with that, let's get into the first feature of React 18. So the first feature that I'm going to be talking about is the Create Route API. React 18 actually introduces Create Route API. Before React 18, we use something like React DOM.render to render a component to the page. You may be familiar with this. Going forward, we won't be using React DOM.render directly, but instead we'll be using something like React DOM.createRoute. So the way this looks in action is you remember this code probably, you have a container element, and then you use React DOM.render to render your app into that container. With React 18, we'll first create a route using the create route API. So we'll do const route equals React DOM.create route, pass the same container there, and then we'll render our app to the route. So instead of rendering directly to the container, we'll be using the route to render our app there. So the idea is that the root that used to be root is actually not a new concept in React. Root was previously opaque to the user, but going forward, root will now be directly accessible by the user. Root is actually, if you're not familiar with what root is actually a pointer to the top level data structure in React that React uses to track a tree to render and re-render. In the legacy API, which is everything React 17 and earlier, the root was actually opaque to the user because we attached it to the DOM element and access it through the DOM node, the container node, but we never exposed it. Now going forward with React 18, we'll be using React DOM.render. And the good news is that all of your code that currently exists with React 17 and earlier will still work. So if you have React, if you're not using React DOM.render yet, that will still work. If you're using React DOM.render, that will still work. So basically, root is not a new feature, but it's part of the upgrade. It has been opaque to the user, but now we'll just be able to use it. Why did this change happen? This change happened because with the help of root, all of the concurrent features of React are uncovered. So we'll be able to use other features like automatic patching, start transition. So root makes all of those new features available to the user. If you currently have code that is still using React DOM.render, it won't break your app. But if you open the console, you'll just see a warning like this that says React DOM.render is no longer supported in React 18. Create root is recommended, and your app will behave as though there is no concurrent rendering. So everything works as is. It's just treated as a legacy app, and it will work as though there is no concurrent rendering. All right, so the next bit we're going to talk about is automatic batching. As the name suggests, automatic batching is how React batches multiple state updates into one. Previously, also React batch state updates, but it only batch state updates that happen in a single event callback. So for example, for example here, you can see here that there are 3 state updates happening: set is fetching, set error, and set form status. Previously, React did not batch state updates like this if it happened within like a promise. But going forward with React 18, all of the updates, even if they happen within a promise, a set timeout, they will be batched. The good thing about this is that it helps to prevent multiple re-renders. And I'm going to open a file here and try to see if I can share my screen. Opening Code Sandbox. Okay, I'm going to try to share another screen and see if that works. Stop sharing this. Cool. Thank you, Dustin, for sharing this again. Looks like it's too small, so I'm going to inspect this console. Hopefully I can make it bigger. There we go. Okay, refresh this page. Cool. Some errors in the console, but nothing that looks crazy. So let it reload. Give it a few minutes. Okay. Meanwhile, that loads. We can see here that in package.json, I've already updated my React to React 18. I have this alpha version and React DOM to 18 as well. And once I go to my index.json file, oh no, this broke. Let's reload this again. Live coding. Okay. Meanwhile, this is loading. I'll explain what the code is doing. So basically, in this app, we have like a handle click function. It's an event handler. React previously batched something like this already. React 17 and before would batch something like this. So this wouldn't cause a re-render. But something like this did not batch before. So React 17 did not batch anything that happened within a promise. But going forward with React 18 will be able to batch anything that happens within a promise as well. So that will reduce the number of re-renders. Now, if I was to run this code, what I would see is that set count and set flag within the handle click would be considered as though it's happening in one single batch. But this set count and set flag would return a console.log for every single line of this. So if I had multiple set events happening, I would see console logs for each and every item of this. But that just basically means that our app is doing a lot more work than it should be. Instead of batching all of these together into one set update, it's actually rendering the app every single time it sees a set state. So as you can imagine, that's a lot of work for the app. But going forward with React 18, this will all be counted as one single batch. So now React will see two batches, one outside the promise in this click handler, and one inside the promise in this click handler. So the number of re-renders reduced from 3 to 2. Now going back to the presentation, I'm going to try to share my screen again. And Dustin will share it. Thank you, Dustin. Cool. Okay, so basically with React 18's automatic batching, it helps to prevent multiple re-renders happening in the app. Behind the scenes, what was happening was React will see multiple set updates, and it'll try to like add it to a micro task, but anything that was happening within a promise would not be added to a micro task, so it would be considered as a separate state update. So kind of an easier way to think of batching is something that Dan Abramov kind of described in a working group discussion. It's kind of like if the state updates are not batched, it's kind of like you are getting groceries on demand. So you start cooking something and you think like, oh, I need milk, so let me go get milk. And then you start adding it to your coffee, and then you realize you don't have coffee grounds. So you go to the grocery store and you get back coffee grounds, and then you ground them. So you haven't really like prepared a list of items that you're gonna get or that you need. So you just have to like go to the grocery store on demand. Whereas batching, it's kind of like you think about everything that you need. For example, you're making pasta, you make a list of items that you need for that. You write that down, you go to the grocery store, you bring it back, and then when you start doing your actual cooking, you have everything ready to go. So you basically like plan and you batch your grocery trip. So that's basically what automatic batching is. Automatic batching is like you making a planned grocery trip. A cool thing about automatic batching is that it's available out of the box. But if you do need to opt out of automatic batching for whatever reason, you can use something like Flush. You can use Flush Sync to opt out of automatic batching. Now let's look into one of the concurrent rendering features, which is start transition. Start transition can be basically used to mark certain updates as urgent updates. So you can think of something like searching in Google, for example. I'll see if I can play this video here. So let's say that we are searching in Google. So as you type, the data starts popping up, right? And that's the form giving you visual feedback that it's typing in your content, it's taking in your typing words, but also it's searching for it at the same time. Now, this is great on a fast network and on a fast computer. But what happens if your computer is really slow? Let's simulate a slow computer here. So I'm going to type here. I'm going to type the same content again. And as I'm typing, the search is not happening at the same time, but still I can see in my search bar that I'm writing content. So I'll play that again. So as I'm typing, Search is not happening at the same time, but my search bar is updating with the content that I'm putting in. So that's what an urgent update is. An urgent update is when you're writing in the UI or you're writing in the search bar and you want the UI to let you know that something is happening, but some things, such as searching for that text, can be delayed. And this is specifically useful, especially if you're either have a slow connection or if you have a slow computer. So with the help of start transition, you can mark those urgent updates and you can mark those urgent updates to show faster, and you can mark those non-urgent updates to be as transitions, which basically tells React that if an urgent update comes in, this non-urgent update can be delayed. So basically, in our context, it means that when I'm typing in the search bar, React will interrupt any non-urgent update when I'm typing in the search bar, and then searching can be marked as a non-urgent update or a not urgent or a non-urgent transition. So React knows that when I've typed the content, search later, but defer searching until I finish writing the content. So for example, in code, it kind of looks like this. We can import start transition from React 18. And to mark you do the urgent set state as you were doing before. So set input value is an urgent update, it goes as is. But anything that's non-urgent is marked within the start transition boundary. So we can put it in the callback and we put the set search query, which is going to be a non-urgent update within start transition. Now you may be thinking like, okay, what if I want to show maybe like a loader screen when I have marked something as non-urgent? So for that, there is a hook called use transition, and use transition also gives you is pending and start transition. So you can use that and use is pending to kind of show like a loader block. Another question to think about is like, where can we add start transition? So start transition can be used to mark non-urgent updates, but it's specifically helpful in two situations where one, you have slow renderings where React is doing a lot of work in the background. So for example, if you're rendering a lot of data, if you're rendering a big map, if you have multiple tables on the page and you have to switch between the different tabs, that's when React has to do a lot of work, and start transition can be very useful there. Another case is where there's slow network. You can use start transition there as well, but currently it needs the support of suspense to enable start transition. So to determine what would be a good candidate, there's some questions you can ask. For example, in this UI behavior, which one of this is an urgent update versus which of these can be delayed, can be deferred, and what do you want to do when the state is updating or when transition is happening. And when you do transition, what do you want to do after the transition has taken place? So overall, the big theme of React 18 has been concurrent React. The main objective of React 18 has been to fix janky experiences and improve the UI performance. React 18 adds a set of new features, which is called concurrent features or concurrent APIs, and they rely on something called as concurrent rendering. And concurrency is no longer something that you have to opt into. It's no longer a mode. It's just provided to you out of the box. And it's an enrichment that happens as you start using concurrent features like start transition and automatic batching. Concurrent React is basically a way of keeping your pages interactive, even if they're doing a busy thing, even if they're actively doing other things. And it can be used, and things like start transition can be used for expensive state transitions. So another question you may be having is, how do I move to React 18? Now let's look at the code of how that can happen. I already showed you that in your package.json, you need to have React Alpha. So you'll do npm install React Beta at this point. The next step is once you open the place, or once you open your index.js where you have your app rendered, instead of doing React DOM.render, you'll do React DOM.createRoot. And basically everything else stays as is. So 2 steps, npm install React Beta and React DOM Beta. And then the next step is to update from React DOM.render to React DOM.createRoot after creating that root. That's all that's needed to update to React 18. And your app should work as is. Another thing that I wanted to point out is a few discussion threads in the React 18 working group's GitHub repo that I found super helpful, especially for understanding React 18 topics like concurrent rendering and start transition. The first one here I want to show is this thread by Sylvia. And this thread is kind of like a community sourced thread on things like Explain Like I'm Five. And it talks about like transitioning, state management, updates, concurrent rendering. So this is a really good resource for learning anything about React or even React 18. Another awesome example of seeing track transition with like fast computers and slow computers is a thread that Rick started, which talks about some real world examples of using start transition, which is a great read. Okay, so far we covered the React features of React 18, create root API, automatic batching, start transition. We talked about what's concurrent rendering, and we talked about how to move to React 18. That's all I have for you today. I hope this was useful to you. If you have any questions, you can feel free to reach out to me on Twitter or post it in the comment here, and I'll try to get to them. I will send a synopsis of this in the end of this week to my newsletter. But other than that, thank you so much for coming, you guys. You can find me here.
All right. All right. Virtual applause. We still need something better than we have right now, don't we, Shruti? What a wonderful talk. What a wonderful, concise, informative way to introduce us to React 18. So, Shruti, thank you so much for that. Everyone in the audience, if you have any questions for Shruti, drop them in the comments on YouTube. If you're watching a recording of this after the fact, you can tweet Shruti at Shruti Kapoor08, and we'll drop that in the comments as well. But for now, Shruti, we're going to say goodbye, and we're going to thank you so much for your time. A little abrupt, Mr. Dustin. Okay, so our second speaker tonight is an engineer, a tech speaker, and blogger with 10 years of experience in web development. And he currently works as an engineering manager at This Dot and actively contributes to free community resources through This.media. And tonight, he'll be speaking about how to create modern Jamstack sites with dynamic content while still making it easy and accessible for non-technical folks to write the content without the need for a backing CMS or design editor. So I'm pleased to welcome to this virtual stage, Dustin Goodman.
Hi, and I apologize to Shruti now for that abrupt exit.
No worries.
Thank you for that wonderful intro.
That is the price we pay for these virtual events. Buttons have consequences. Immediate.
Immediate, and there's no taking it back. So apologies, Shruti, but thank you for the great intro, Ben.
Well, since you're in control, feel free to cut me loose whenever you're ready and get going on your presentation.
All right, thanks, Ben. Oop, too abrupt again. All right, well, thanks everybody for coming tonight. I'm really excited to be here and talk a little bit about powering static sites with MDX and Tailwind to give your site some really enriching dynamic content. And this is really fun to talk about as well. And I'll get to why in just a moment. A little bit, Ben gave me such a wonderful intro, so I'll kind of abbreviate it as well. But one thing I'll point out here is you can find me on Twitter at Dustin S. Goodman. But like Ben said, I'm an engineering manager at This Labs, part of the group that is sponsoring tonight's event. And just a quick little thing about This because it's relevant to my talk tonight, is we have some really amazing clients, some of which include, and I need to change this, it's now Meta, but Facebook and Cloudinary specifically, where we actually got to implement the solution I'm going to talk about tonight to actually implement some features with them. And with Meta specifically, we got to help them create a MDX and Tailwind-based component library for the React documentation site that is going to be accompanying the React 18 release, we hope. We'll see if we're able to get all the content done. And of course, we are hired, so if any of those sponsors ring a bell or anything you hear tonight is interesting, throw throw us an email at hi@this.dot or DM me or us with any questions, and we'd love to talk to you, even if it's just to talk tech for a little bit. We love building the community. So tonight we're going to take a really quick journey through the power of an MDX and Tailwind stack. And what I want to do is I want to start with a quick kind of intro into what each tool is, and just to make sure we're all on the same page about what it is. Then I want to talk about some of the reasons these stacks were selected. And then I'll show you a little bit about how we integrated this to actually create a really nice development experience for some people. So let's quickly explore what these are and how you can build some pretty amazing static sites. For starters, MDX is a library that's going to allow us to use JSX in your Markdown instead of just JavaScript files, which is going to be really awesome because now what's going to happen is we're going to take our traditional Markdown and actually componentize them. And in traditional in traditional Markdown, we had to create some global style sheets to override kind of how things were rendered, or we'd have to pull something like remark in to render our content. And there's a bunch of different ways in which we could do this. But with MDX, everything's going to become a component. And this is going to really be great because it's going to allow us to use React to hide in our code bases and make it easier for us to build sites that we know and love, but produce kind of faster user experiences for our users. And what's really great is every Markdown construct that we're traditionally used to is going to be able to be customized further with React component syntaxes. So we're going to be able to do some pretty amazing things. And then additionally, MDX is compiled at build time. So this is going to allow us to have a lot of static content. But of course, if we have dynamic features in our components, we're going to be able to leverage those and show them to the user and have just really nice, rich content. And I'll show you some really great examples. But from the MDX site example, it would be remiss to just not look at a little bit of syntax, a little bit of code, and then we'll look at more code later, of course. But in this example, what you can see is on the left, we have a MDX file, and you'll see some very familiar JavaScript-esque things where we're importing and exporting content. And then later in the file, you'll see that we're doing some string interpolation and actually rendering a component. And all of this is in a Markdown file or an MDX file. And on the right, you can see kind of that output and see how we're going to get the H1 that we had, the little paragraph text, and then this chart with the content that we passed in specified by properties. So this really yields nicely to the experience we're used to building. And what's going to be awesome is it's going to create an experience for content writers later. And we'll talk more about how you're going to kind of design around that to make just an awesome development experience for content. Now, on the other tool I want to talk about, and you've all maybe heard too much on Twitter, you might be sick of hearing about it, but I really just want to promote like Tailwind Css. It's going to be one of those libraries that's going to give you 98% of all the CSS classes you probably need to build any component or any library. And what's really amazing is out of the box, when you want to get started building a site, you can just go ahead and opt into their default rules, or you can reconfigure any of their values to, or any of their classes to anything you want, which makes it so as you're kind of designing values and components, you're able to really make a decision early and then reconfigure that decision later without any major like lift and shift of your code. What's additionally amazing is it has its just-in-time compiler. So what you can do is you dynamically generate classes and define some of your own custom classes that you need to be having in your style sheets at the end of the day. And what's amazing is at build time, Tailwind's only going to pull in the CSS your app utilizes. So it's going to keep your CSS bundles and style sheets really small. So you don't need to worry about any manual CSS optimizations or style sheet manipulation, any code splitting. Tailwind's going to make it so this is a really smooth experience for you. It also ships with some amazing utilities for responsiveness and interaction design, as well as dark mode. So you could do a lot of really niche and specific things as needed. And all this just yields really nicely to component design. When we're designing our components, kind of like with MDX, we're going to want to be designing our components to be kind of unique elements. And what's really great about this is with Tailwind, if you've ever used it in just a plain static HTML site, you find that you repeat a lot of the same content and class names repetitively. But when you have a component system, what you can do is you can now abstract that repetitive element into a component list your component. And now whenever you need to globally reset whatever the styles are on that particular component, you have a single home for editing that and just making those classes really easy to maintain. And this makes it a really amazing tool for any project of any size. So now that we kind of understand what these tools are at a high level, let's discuss some of the things you should consider while choosing this stack. So first of all, they're a perfect harmony for one another. Both MDX and Tailwind have build-time processes that make for great optimizations for static sites. And this is going to make it so your overall user experience is just that much faster, as when you're trying to serve the assets, you're not having to do any runtime compilation, which slows down sites. And you can see that the mood of the React ecosystem is absolutely moving further and further towards static site generation. And what's also great about both libraries is they really want to exist as part of components, making them a perfect partner for frameworks and libraries like React, where you're trying to separate out elements. So if we look kind of just really quickly at a simple Google search for Tailwind and MDX, what you can actually see is there's a lot of blog posts and resources specifically about using it in React applications, and something you should really get kind of hyped up about as you see more and more of these projects existing. And what's also super amazing about these is that they're first-class supported in most of our favorite frameworks. So Next and Gatsby, for instance, have great first-class plugins that you can just utilize and get running with MDX out of the box. What's really great about Astro is that it's now shipping with MDX out of the box. And I'm sure a lot of us have been hearing a lot about Remix. And they're strongly encouraging the use of Tailwind. Their style system really supports it. But then additionally, with Remix, you're really starting to see MDX become prevalent out of the box as well. So you can kind of see as we're shifting more and more towards these new frameworks, as we're looking at our not old, but good frameworks, we're seeing that these are just tools that yield real nice results with our existing technology choices. So because we're seeing more of this, what is this kind of focus good for? It's good for a content-focused approach where we're building static sites such as blogs and documentation sites. But other rich sites, kind of like marketing sites that need good SEO and fast performance, this is going to help us build those types of sites. Now, as JavaScript developers, we really want to utilize our favorite framework, and we want to be able to use JavaScript tools to generate these pages. But at the end of the day, we only want to serve, or at least get as close to serving, just pure HTML and CSS to our clients. That way they're not having to deal with JavaScript. They don't really want to run JavaScript in the server, or not in the server, on the client. So in our classic model, the way this would kind of work is we would have a CMS where somebody's having to go design things. Not really ideal for us. On the other side, we have headless CMSs, where we're going to enable content writers to put exactly what they want, but then we have to pull in that content and decide how it's going to be rendered. But both approaches have their limitations. CMSs are going to make it so marketers and other people are going to have to decide what layouts are going to look like, and you don't really get to use your favorite tools. On the other side, with headless CMSs, you can't be as dynamic with the content, and so you're going to have to create complicated data models, sometimes making it really hard for marketers and whoever you're working with for content to really figure out how they can put things on a page. And what's really great about this new approach is we as developers get to create components that are concerned with display, and we can give our content writers and marketers very easy to use markdown and code styles that allow them to write the output without really having to think about it. And this was our main motivation when working with the React team. Rachel specifically said, hey, I want to make sure that all of these components are really easy for me to use when I'm writing content. And we said, okay, we think this nice combination of Tailwind and MDX are going to make for this great experience. And as you can kind of see in this example, I've kind of pulled a little excerpt from the React. If you haven't seen it, it's beta.reactjs.org. And what you can see on the left-hand side is what the underlying render code is for the right-hand display. And what you can see now is it's mostly Markdown with a little bit of markup around certain section types. But at the end of the day, we really understand what the flow of the content is. We kind of understand where the logical sections are. And we're able to create these really nice experiences for the content writers, but allowing us to write really good JavaScript React components. And I'll go into that in just a minute and show you some specific components. So now that we've kind of seen why we want to do this, let's look into some of the setup we can do to get there. For time's sake, I don't have a ton of it. I'm going to skip showing you all of the available plugins and setup, but just know there's a blog post or an article that explains the exact setup you want for your exact site. So definitely go check all those out. In the meantime, though, let's talk about a couple things that you might actually have in your code base that are worth looking at. First off is MDX, sorry, not MDX, the MDX components file, which is going to be a great way to kind of create a single export for your entire component library. And Next.js has a great integration for this, where it actually checks for this file and injects it into every MDX file that you then generate thereafter. Now, not every framework works this way, but we think of this as a really great way to kind of keep your component library together, because then you can have a single file that you need to then extract out for your documentation's sake when you're handing it off to your content writer and being like, hey, here's what you have available now. And what's really great about this too is it gives you a layout for how to style all of your different tags. So for instance, like I mentioned earlier, MDX says you can style a p tag any way you want. Well, now you can pass in your paragraph component or its equivalent and style every p tag that way within the rest of your JSX or MDX. Similarly, with console block is going to be another example I'm going to use, and I'll show you the exact code for that. Now you can use that inside of your MDX files and show console blocks in a certain way. And this is going to be really nice if you have some of your components that have props that are used to control its display as well. So in this case of the console block, you might have an error or a warning or an info style. And using this MDX file, you can create the one component, but then you can expose it to your content writers as a set of warning console block, error console block. So let me show you, and let's dig into the code just momentarily. So in our example here, I'm going to show the console block. But as you can see, console block is just imported. And at the end of our MDX file, and you can see through our MDX file, we're also styling our p tags, strong tags, ordered lists, list items, etc. Once we get to the bottom, though, we see we just have a giant export of all of our MDX components that are then later consumed by the engine. And you can see here that we have our console block, and we're just generically exposing it. Now, another example here, though, is the expandable example, where it actually is driven by a type parameter that could be used in a variety of ways. Now, in this example, you'll see that expandable example was only used one time and only has one type that's now exposed. There was a time, though, where there was another type. And this gives us some variety and availability here for a content writer to be like, hey, I'm going to write about a deep dive right now without having to be like, huh, is that an expandable example? Oh, should it be a code diagram? I'm not really sure. So looking at the console block real fast, we can see here using TypeScript, we've defined some nice little log level types that are now passed in as props into our console block. And you can see it's passed in as a log level. And as far as the MDX component is concerned, you can see that it's just ingesting the children, which is the content, and displaying it later down the line. And within the component itself, what it's doing is we are just using the type to define all the different styles that are applied using class names and Tailwind properties. If you're curious where the children actually went, they got consumed here in the messages and later dropped in down here, given some nice little padding. And it creates just this very clear cut how we're going to implement this component, how we're going to see it, how we're going to display it. So if I wanted in our code base here, what I could do is I could remap console block to be something like warning console block. And like I did with deep dive here, I can make a console block with the type warning, the default, and then that would be the element that our content writers would use later. So to show you how this ended up rendering at the end of the day, because we like to see how the code exists, we can see our nice little console block with an example. And if we look inside of the actual markdown file that was used to generate this section, we can see that our content writer didn't have to concern themselves with how the shape would be laid out. They just had to be concerned with, I know I'm going to have content warning. Each child on the list should have a unique key prop. And they placed that within our console block, gave it an error level, and sure enough, there we are. Now, thinking in MDX and Tailwind is really important. We're going to be designing components for an MDX library in a very different way than we would a normal component library. Like we saw in our last example, it's going to be great to obfuscate as much of the necessity to name things, alias things. We don't want to use prop types as much as possible. So as a result, we need to defensively program our Markdown components to know how to handle components the way, to know how we don't want to handle other elements. For example, let's say we only want a component that accepts code blocks and a special other internal component that we've defined. We now need to be more defensive towards any other elements that get passed in, such as header tags, list items, etc. So what we have to do then is we have to do some parsing and then take that and then lay it out ourselves. So now our components have to be a little smarter. And again, the React docs were a great story for this, and I'll show you another example. So this was the API anatomy component that we designed specifically to tell the story of hook anatomy. And we probably should have renamed it to hook anatomy, but for the time and sake of this, API anatomy was great. And as you can see, it accepts anatomy steps, and it also accepts a code block or a pre-tag. And there's some other properties here, and I can go into a deep dive of that a little later or another time, maybe on Twitter. Y'all can reach out and ask me, why did you do this? But this is a great example of kind of showing how a content writer could very easily list out the information they care about without worrying about the layout itself. Because at the end of the day, the way this component ended up laying itself out would be this display of the 3 API anatomy elements with the code block to the right. And so we can really see how the structure wasn't defined by the writer, but the content was. And to show kind of where this kind of differs from our traditional component structuring, wanted to show kind of how we're parsing children in this example. So in this case, our children are going to be parsed out using a reducer, where we go through and we say, if it's not a valid element, let's throw it out. And then in the case of this component, we only care about anatomy steps and the pre-tag, like I mentioned, where then we have a different specific handler for our end result of our reducer, where if it's an anatomy step, we include it in our steps array. And if it's a code block, we add it to code. Now, there may be an argument, well, what happens if they put 2 code blocks? We need to have a little conversation, maybe a little more handling around that particular case. But now we can see we're having to think a little bit more about parsing our children rather than just passing them down and displaying them. So now that we've gathered those elements, what we can do is place them in their respective homes within the larger template. And what's really incredibly amazing about this is, at the end of the day, MDX made all the difference in designing the layout of these components and in designing how we would structure the data flow of components relating to each other. But when it came to the inevitable design, if we needed to iterate and change things, all we had to do was come into these components and change the the classes and the CSS, which Tailwind made a very easy job of. And in the case of some instances, we maybe decided, hey, we need to increase the amount of margin, like MY-8, for instance, is a vertical margin of, I believe, 2 rem. Let's say the default instead for 8, we decided instead of a rem of, I think 16 pixels is the default, let's say we wanted it to be 18. We can now configure that in our Tailwind CS configuration file. And now it expands to the rest of the entire project. And we had to do minimal changes to get a lot of results. So if you have any questions, definitely please ask them to me in the chat. I'd love to answer them at the end. I know Ben definitely, I'm going to bring Ben back on because I also need to be managing who's on and off stage. Here we go.
Hey, excellent. Another semi-virtual round of applause. Well done. Thank you so much. That was quite an interesting talk, and very concise and very, very, very content heavy. So I do really appreciate that.
Thank you. Well, I'll leave the stage to let you do the next intro for Ken, but really, thanks for having me, and glad we were able to talk. If you have questions for me, at Dustin S. Goodman on Twitter, and I'll be in the chat.
All right. Thanks so much, Dustin. Well, some say that our next speaker was the muse for the hit television show Jersey Shore. Others are convinced that he's actually the man behind the mask of the popular EDM producer, Marshmello. And some have even gone so far as to rumor that he writes pretty decent JavaScript. Whichever you may believe, you can find him tweeting at Ken_Wheeler and oftentimes speaking at conferences around the world. And tonight, he's going to talk to us about 808s and line breaks, how new APIs like Audio Worklet can allow us to do smooth real-time digital audio signal processing right in the browser. So I'm pleased to welcome to the stage the one and only Ken Wheeler. Ken, how we doing?
I'm doing great. How you doing?
Doing pretty good, man. Looking forward to this talk. How you feeling?
I'm feeling good. You know, I had a little coffee and shit because it's like 10 o'clock at night, but I'm feeling good.
All right. Well, I'll let you take it away, man.
All right. You got my screen up here. I guess I'll full screen the thing. It's going into wild mode. All right. Hey, everybody. I'm Ken Wheeler, and this is my talk, 808s and line breaks. And this thing is in the way of my slides. So I'm going to move that thing over. All right, now we can party. Hey, everybody, I'm Ken. This is a 60-minute talk that I'm going to give in about 15. So I'm gonna cut all the BS. I'm Ken_Wheeler on Twitter. I talk shit professionally on Twitter, and that's what I do. But today, I'm going to teach you how to make 808s with JavaScript. So if you're not familiar with what an 808 is, an 808 in the literal sense is a drum machine that you see here, right? The Roland Tr-808, Tr-808 rhythm composer. And it was introduced in 1980 for $1,200. Now it's basically $12,000. And it was one of the first drum machines that allowed users to like program their rhythms with step sequencing. And it was used on more hit records than any other drum machine. It uses analog synthesis to imitate acoustic percussion, meaning it's not like recorded samples of drums. They're synthesizing those drum noises, making synths sound like drums. And it's kind of wild. I looked under the hood, and like when I created this other thing, like it's like 8 different tones to make a hi-hat. It's wild. I even made one in Reason ML. I made a little bit of a recreation where the whole front end was in OpenGL and the whole back end was written in Reason native code, just hammering the sound card directly. Kind of wild, right? But I'm here to talk about a different kind of 808 tonight. That's like the old like Beastie Boys having fun kind of 808. I'm here to talk about 808 bass, which if you talk about 808 colloquially these days, generally speaking, you're talking about the bass in an awesome trap song. So what is an 808? At a fundamental level, it's a sine wave, right? I remember being in class and had to get this calculator thing, and I'm like, when the fuck am I ever going to use that? And then yeah, it turns out pretty extensively. So it's not just a sine wave. The way that you do it is you have this thing called a sample index, right? And we'll get into that, right? That's where you are in the period of the wave. You divide that by the frequency, right, which is the speed with which it oscillates, divided by double pi and the sine of that, right? And what that gives you is based upon those parameters is one of my favorite GIFs ever is this oscillator here. So all of your all based around that right there, right? So how does it turn into bass, right? How do we turn this nerd math into cool bass? Well, I'll show you how to do it with the Web Audio API. So the Web Audio API is a built-in web library for dealing with audio on the web. Lets you play music, synthesize sounds. You can route and add effects in a signal chain. It's like a graph setup. It's pretty awesome. And they also have hooks for utilizing real-time audio data and visualizations. So if you want to like take that and make like a Winamp style visualizer, you could do that. I'm going to back out for a second and just show you some basic Web Audio API because it's kind of crucial to this talk here. So here I have this code pen, right? We have like a play button right here. Oh yeah, that's awesome. That That's fantastic. Okay, so it's going to start up. I'm just going to play. I'm going to turn my speakers up so you can hear the actual tone. Right? Okay, speakers back down. So what happens here is I'm adding an event listener on my tone. The first thing that we need to do is create this audio context, right? And that is kind of like the root level of everything. And then you create an oscillator. It's got a built-in oscillator creation method. And then you can set different parameters on that oscillator. An oscillator is a type of audio node. And audio nodes have parameters, and I'll get to that in a little bit, but it's the way that you tweak internals of them. You call oscillator start, oscillator connect to the audio context.destination, which is essentially like master out, and suddenly we have music. All right. I'll get back in here. Come on now. Right. So getting to audio worklet. The web audio API is great, but if you want to do anything completely awesome, sometimes you want to go under the hood. It's almost like using like an abstraction like React versus writing vanilla JavaScript, or even like, compiling to like WASM or something like that. Like, if you want to really mess around, previously what you would do is you do what's called a script processor node. And that would let you take in the raw audio data, do algorithmic signal processing on it, and then send it to the output, which lets you, for example, build your own effects or something like that. The problem was it was kind of clicky and it wasn't really like top tier. So they introduced this thing called an audio worklet, right? And what an audio worklet it does is it lets you do low-level threaded keyword audio processing, right? So you define a worklet module and then you register it. And you can import it in your main code and add it to your signal chain, because it's essentially what it is an audio node, right? It's a first class node in your graph of audio things. And it works just like an audio node, but each one is, it's off thread, right? So this is kind of what it looks like. This is a basic one where it's a class, right? So you inside of your actual worklet, you define a class and you extend audio worklet processor. You have this little constructor, and then this is where the magic happens right here in this process method. You have inputs, outputs, and parameters. And then you're going to take your inputs in here, you're going to mess around with them, you're going to loop over them, right? It's an array of floats. And then you're going to assign them to outputs, right? So if you say like output I is equal to input I or something like that, right? It's just a direct pass through. Now, if you do stuff in the middle, that's how you get things like effects or synthesis or what have you. And then you call register processor right here, which kind of lets it be available for use, right? So using these worklets. In part of some other code that I'm going to show in a little bit, we have this start audio method. Here we have an audio context just like we did prior, but here you use audio worklet, add module, and then the path. And then you instantiate it right with your current audio context, and you connect it to wherever in the audio graph you want to, and then you're up and running. And the thing is that you can connect that at a bottom in between other nodes, right? It's just a step. It's like a function that you have in a like wrapped functions here. So for this processing, right? If you connect an audio node to this node, you're going to get input, right? And the output is what you're sending out that any subsequent one or the destination will receive. And parameters are things that you can define and tweak in real time, like option sets, for example, right? So digital signal processing. It's a much more than just making beats. You can do audio processing, synthesis. People use it for statistics. Well, it was funny. I found out that some of the same filter algorithms that you use for making a rap song sound like you're in a club basement in the beginning of the song when Drake's talking shit. People use to remove outliers in data science. Wild shit. People use it for medical data, medical applications, image, video processing, denoising, etc., all kinds of stuff. But it starts off in an array, right? So you have a sample rate, and that's the number of samples of audio per second. Right? It's your resolution. So if you've ever seen like on the side of a CD player, or in your like Winamp settings, like 44.1 kilohertz, right? That's 44,100 samples per second. That's the resolution of your audio. When you're looking at this wave, each line here represents a new one of those samples, right? That makes up all parts of that, right? And what that wave is it's a waveform, and different waveforms when you do synthesis is what gives you different noises, right? So you have a sine wave, right, which is like an 808, like doo, doo, doo. Or you have a square wave, which is like if you're like some like UK rap kind of shit or something, or like a sawtooth, which is like dubstep, it's like wah wah wah. So they can emit these values over time, right? That's how oscillators roll. And frequency determines how fast it oscillates. So if you're looking at a wave and it's higher frequency, like doo, right, you're going to see much tighter waves. Whereas if it's like doo, right, you're going to see much longer, more relaxed waves. And time determines where in the cycle, which is called the period, you are, which is the phase, right? So you have your period, right, which is the period that it takes for a full oscillation, and the stage of that and the offset of said stage is the phase, right? So let's make a sine wave. So if we have a class, right, where we want to create a sine wave that's changeable, right, we can have some initial properties up here like sample rate, current angle, and angle delta. The reason that we calculate these angle deltas is when you have a wave going, and then when you change the frequency of it, what you need to do is you need to match it up so that it doesn't so that the two ends connect properly, right? It'll flow into it smoothly. Otherwise, you have a real problem. It sounds bananas. The thing just goes not cool. I'm just gonna head back real quick just for 1 second. So in here, right, we have get data. Whoa, get data. So for our current sample, right, we're gonna say that is the math.sine of our current angle. Get data gets called for every single sample. So we're saying get data, which is like based upon this point in time, what's the value? And the value here, right, is going to be the float that represents the point at which you are in the oscillation. We'll get to volume and stuff in a little bit. So here in your processor, you're going to loop over your outputs, and you're going to loop over the channels of the output, and then you're going to say that output, the indexes are equal to this dot tone, right, which is sine, get data, right? So volume and gain. When you listen to music and you have your wave here, right? This is like the normal one. If you're gonna multiply those numbers by 1.1 or any gain multiplier, right? Obviously the thing's gonna get taller, right? So here we could say the same thing as before, but times this dot gain. So gain right here is 0.5. So we're saying take it down half volume, right? Because the initial get data might be a little harsh because it's all up top. Right. So how can we shape this sound? Right. Now we just have tones and they're just like do do do, right? How can we make them like notes, like do or do, right? That kind of thing, right? And that's called an envelope. And what an envelope does is, if you've ever done like web animation and you know about like a tween, right, where you're going in between 2 points, or you have like a curve on an animation. That's sort of like what's going on here, except what you're doing is you're tweening the volume. So here, when you define an envelope, you have an attack, decay, sustain, and release. And that's over time, right? So it changes the amplitude of a signal over time. So the attack is your initial ramp up. If you have like a flute, right, it's gonna be a long attack. It's gonna be like, whoo, right? Whereas like a drum, it's very short attack, just burp, right? The decay is the initial step down, right? So if it comes up and then down real quick, that's your decay. The sustain holds your amplitude steady while you hold your finger down, and the release is how long it takes after you've released your finger for it to fade out. So if I say like do, right, that's your release. So I built a thing kind of demonstrating some of these concepts and using audio worklets just to show what they actually could do. What I have here is this thing, which is a bass plugin here, and this uses audio worklets right here in the browser. You can't hear it. I'll turn up my speakers, but now, as you can see, like I was talking about before, we do a low note and look at the waves on the oscillator. And then you go up high and you're going to see much tighter waves. I'll stop making noises right now. But this is your envelope and this is your oscilloscope, and here is the gain, right? And then we have a couple different things like the glide between the notes, the saturation, the thump, which is just a in the beginning, some bit crushing, some low pass filtering. It's pretty cool, and I'm going to go into how that actually works in the context of React, right? So first I want to show you my audio worklet. I showed you some kind of like funny examples. I want to show you just real quick what this stuff actually looks like, right? So here are some properties that I have in here. I have a bit crusher. I have a tone. This is a pitch envelope. So an envelope you have on gain, but I also have an envelope on pitch. That's how thump works. You do a quick tween on the thing, and that gives you a woo, right? So in here, if we look back just for a second at this code sandbox, here we have like oscillator frequency value, right? That's a parameter of an audio node. So over here and here, this is where you describe those parameters, right? So for mine, I could say like the sample rate, the frequency, the gain, the attack, decay, sustain, release, trigger, because you don't have actual methods inside of this. So I have a binary trigger here. And if this goes from 0 to 1, it's on, 1 to 0, it's off, right? So you're not calling like play or stop or anything. We have saturation, thump, crush, etc. These are just some processing steps, things like soft clip or distortion, right? This is just operations on the stuff. But here, let's just take a look at the process method. So here, right? So we get our outputs. And we don't have any inputs because this is a synth. It's generating sound, not operating on it, right? So we could do whatever we want here as far as the output. I'm using this trigger here to control the stage of the envelope, a lot like a state machine almost. So it'll enter into these different stages, and then when it hits the different points, it'll transition into the next one. But down here, this is the bread and butter. This is where we actually generate this data. So we say output OC, right? For each output, for each channel, I say generate audio data, right? And I pass in like our current time, and I pass in our current parameters that we grab. And in here, this is your pitch modulation. Don't worry about that. We have our frequency that we get. For our tone class, right, we update the frequency to what the current frequency is. And we say the tone is this.tone.getData, right? So then for our envelope, right, which is our tween of our gain, we're saying get multiplier, right? So this is going to be the tweened volume. Let's not worry about distorted or crushed. These are pass-throughs at this point in time, but we're going to say basically tone times envelope times parameters.gain, right? So like a normal situation, right? If we had like 0.6, that was like our data at any given time, our particular float, right? And then we do times 1.0, right, which is like a top of the envelope, like a sustain, and then times like 0.5 for the gain, right? And that gives you a big ass array of numbers that magically is turned into sound. It's unbelievable. But that's how it works. That's literally it. And it's funny, like this is just one tone, but when I was building this out, or building another thing actually, I was like, oh, so like what if I want to have a polyphonic synth, right? Which is a synth that has more than one tone. If you do music at all, right, you or synthesis rather, a lot of the time, a lot of these sounds will have like 3-4 different tones in them, all at different volumes, pitches, etc. Right? How do you mix them all together? Because like this is pretty straightforward, right? We're just going and adding this to the array. Like if I have like a couple of these, how do I do it? And I asked somebody who knew about this, and he's like, oh, you just add them. And I was like, what do you mean you just add them? And it's like literally like output is equal to sound A plus sound B, right? So if at that point in period time for that sample, right, like this one was like 0.6 and then sound B was like 0.3, you literally add them. And I was like, it can't be that simple. But fucking believably it is. You literally add the sounds together, and that's how you mix music together with math. It's a mind-boggling. So just a little bit on how this actually works in the context of React, right? So like we have a use effect, right? And this is like the first entry here. We do web MIDI. So that's how I can control this with this keyboard is we have web MIDI. We enable it. I grab my IAC driver bus, which is like a virtual bus in OS X for MIDI. MIDI is musical instrument digital interface, which is a way of it's like note messaging, right? So on these listeners, I say note on and note off, right? So if we have note on, right, we say my frequency is equal to this note number, and then we just update the node parameters here, and that's pretty much it. And because that thing's in play already, we're just tweaking those parameters that we defined. And that's largely what's going on in the React world of that. One other thing that's worth taking a look at here is the oscilloscope, right? So if I were to go back to this thing right here, this is a canvas, right? And before I was saying like you can use it for visualizations. So down here, I just render this canvas right here, and I have a ref to the canvas. For all my nodes, I'm able to, in my context, I can create a thing called an analyzer, right? And I can connect in and set up a fast Fourier transform size. And I'll call draw on this, right? So I'll have this array and I'll call draw. And in draw, I'll do this thing called get byte time domain data, right? Which will give me a big array of all these different things. It's like for the given thing that we're listening to, it's like an array of numbers, and then you just kind of times them by like the height, and that's like the y of kind of what you're drawing here with your line. You're doing like a canvas line 2, and then you stroke the line, and that's I'm not doing anything too fancy here, just feeding into line drawing. It's just literally the data, and it just constantly draws, which is pretty cool. The envelope was a little bit more difficult, but I don't have that kind of time here. That's the short version of this talk. If you think making beats is cool or Canvas is cool, I highly recommend giving this stuff a shot. And if you need any help or recommendations, or want to team up on some hotness, holler at your boy.
All right, Ken, that was really insightful. Thank you so much for that talk.
Anytime, man.
I learned so much from that talk, not the least of which is most interesting, besides the code, was just the whole concept of the envelope. I never knew that was a thing. I'm not into the whole
wild, right?
production. So
Envelopes, man.
I will tomorrow be requesting of my stock music libraries to include an ADSR into their search parameters, because that's going to make searching for music a lot easier. Yeah. So question, your eponymous album, Letters to Your Mother, was this all written in code?
No. So I had a little period there where I got pretty excited about 80s action movie music.
Yeah.
So I wanted it to be kind of authentic. So what I chose era accurate synths or representations of those synths to do it. So I had to do that with instruments and virtual instruments in order to
With
get
actual
that
synths.
sound.
Were they what do you call them? When they're synthesizers that aren't digitally produced, what's the word?
VSTs, virtual instrument.
Yeah,
Oh, analog synths you're talking about.
analog is the word I'm looking for. Were they analog synthesizers, the old school?
So it's actually kind of wild. It's I didn't use the analog synths. I've been off analog for a long time, but what they do have is they have circuit accurate recreations virtually of these. So use those. You can get them right from the manufacturer that originally made it. Getting the actual hardware is a very expensive ordeal, whereas you could pay like $100 and just get like a thing that's like pretty close,
Yeah.
made by the same people.
Oh, wicked.
Yeah, but I mean, I suppose it could have been done in code, but I didn't.
So is this just for demonstrative purposes, or are you actually producing with code? Do you have any songs that you released?
Actually is, yeah, like that plugin particularly. I find real difficulty getting what I want out of software synths for like what my bass should be. So I made that to actually make bass sounds, and I actually use that in songs. The way that it works right now is it's hooked up through Midi through Ableton, so I can actually hit play in Ableton, and as long as this browser tab is open, Ableton will play and this will play over the same sound card. Or if I want to get fancy, I can route it into Ableton and record the wave. But no, this is prod grade.
Nice. Well, really interesting talk. And I'm sure the longer one is even more interesting. So maybe I'll go check out your talk at RenderConf, and maybe all of you out there watching live and after the fact can do so as well. What do you got going on? Where are you gonna show up next, Ken? Do you have any conference talks you have lined up? Any conferences you're attending soon? Or anything you want to let the people know?
Yeah, no. Well, there's another render in June, which is going to be dope. I think React Summit. I think also in June. But yeah, I don't know. We'll see how this. Everything's been so tentative. What with the pandemic, that it's hard to pin down and plan. I've canceled like 7 vacations at this point.
Yeah.
So we'll see how it goes. But yeah,
My
I'll
wedding's
be out
been
there.
postponed.
Oh
twice.
no! Devastating.
Yeah, we had the perfect date, the perfect location.
That sucks.
Postponed. Yeah, it's like all the things. But
All the things.
yeah. Well, thank you so much for the talk tonight. It was really great to see you.
Likewise.
I think we're gonna wrap up there. I think that's a good place. I know it's getting late for you as well, so appreciate you stopping by, and thanks everyone else for coming. It's been a real pleasure hosting all of these wonderful talks from Ken, from Dustin, and from Shruti. So thanks again to This Dot for organizing this. See you all later. Bye-bye.